Good afternoon, my dear students. So today in these sessions we are going to solve the next problem on the trusses. In the second problem, in which we need to find out the nodal displacement and stresses, as well as we need to find out the normal reaction on a two-dimension bar element. Let us see this figure. I will read the question. A truss, as shown in a figure, it is made of two-dimension bar element. So in which, first of all, we need to determine the nodal displacement. So the nodal displacement nothing but we need to find out the value of Q1, Q2, Q3, Q4, Q5 as well as Q6. As well as we need to find out the stress in each element. The stress in the each element nothing but we need to find out the value of sigma 1, sigma 2. And the reaction at this support, as well as we need to find out the reaction R1, R2, R3, we need to find out. Clear here? So let us see this figure. Here the cross-sectional area of this first element is given as 1200 mm square, and the cross-sectional area of the second element it is given as 1000 mm square, and the modulus of elasticity, or we can say as Young's modulus value of E1 and E2, it is given as 2 into 10 power of 5. So the node 1 and node 3 is rigidly fixed. Clear? And pinned this node 1, okay, and node 3 is rigidly fixed, pinned at the node 2. Clear? As well as at the node 2, the compressive force is acting. How much compressive force is acting here? 50 kilonewton. So if you convert in Newton, 50 into 10 power of 3 Newton. Let us see in this figure, the origin point, it is given as 0, 0. So this one is indicate that x1, y1 value. x1 is 0, y1 also 0. Clear? Because of it is the fixed end. Clear here? Then come to the point of 2, or we can say as come to the point of node 2. So here in this case, so x displacement from first node to this up to this second node, how much is given? This one distance x is 750, and this vertical axis is how much is there? 500. Clear? And come to the point from 2 to 3. So here how much is given? So x here 0, it is rigidly fixed, and this vertical direction, how much is there? 500. Clear here? Let us see this figure. The same figure. Clear? Let us see, this is the first node. If you are joining the first node to the second node, the forming of the first element. If you are joining the second node to the third node, the forming of which element here? Second element. Clear? Then let us see the height in the vertical axis. How much is given here? 500 mm. On what basis we have considered this one? Because already they given 500 mm in the vertical direction. For that reason we are considered from the bottom to top the height should be 500 mm. Clear? I hope so. No one is having a doubt. As well as if you consider from 2 to 3, how much distance is given here? Because the distance from 1 to 2 also from here 2 is same, as well as 2 to 3 also same. So for that reason we can consider that this 2 to 3 distance is how much is there? 750 mm. Clear here? Then as well as because the one is, how is it? It is a fix. The element 1, so sorry, the node 1 and the node 3 is rigidly fixed. At that time, what will happen? So the nodal displacement q1 and q2 is acting at a point of 1, as well as the nodal displacement is acting at a point of 2. So it is represented by the nodal displacement q2 and q3 and this is q3 and this is q4. I think so it is not visible properly for you, maybe. Let us see. I hope so it is visible. Okay, this q3 and q4, this q3 and q4 is represent the nodal displacement is acting at a point of 2, as well as come to the point of 3. The nodal displacement is q5 and q6 is acting at a point of 3. Meanwhile, along with the nodal force is also acting. The nodal force is acting F1, F2 at a point of 1, and the nodal force F3 and F4 is acting at a point of 2, and the nodal force F5 and F6 is acting at a point of 3. Clear here? I hope so. No one is having the confusion. After that, I told you we need to draw the one tabular column. So this tabular column we can say that node data. What we can say here? Node data. So here total how many element we have here? So actually we have 2 element, this is first and second element. How many nodes we have? 3. First node, second node, third node. First write down node number. Total how many nodes we have? 3. First node, second node, third node. First node, second node, third node. Clear? Come to the here. In x distance, in the y distance we are measure in mm. Clear? Then so come to the point, come to the node 1. At node 1, x value is how much is there? 0. Y value is how much is there? 0. Clear? Come to the node 2, in which so x value is how much is there? X2 value is how much? 750. Y2 value is how much is there? 500. I hope so no one is having that doubt. Come to the point of 3. Then x value is how much there? X3 value is 0 and y3 value is 500 mm. After getting the node data, we need to find the element connective table. Clear? Let us see. So first of all, we need to write down the element. How many elements we have in this figure here? We have only 2 elements. First element and second element. If you are joining the first node to the second node, we are forming the first element. If you are joining the second node to the third node, we are forming the second element. Is it right? For that reason, we have only 2 elements. First of all, write down this first element and this is the second element. Okay. Here, if you are joining first node to the second node, what we are forming? We are forming the first element. Here, this is the initial node. What we can say here? Initial node. And this one, what we can say here? We can say as the final node. Initial is 1, initial node is 1 and final node is 2. If you join first node to second node, the forming of first element. If you joining initial node is 1, final node is 2. Initial node is 1, final node is 2. If you join one node to the second node, we are forming which element here? First element. Clear? I hope so. Don't have the confusion. Clear? After that, we need to find out which one? Element number 2. In the element number 2, in which if you are joining the this is element number 2. If you are joining the second node to the third node, if you are joining the second node to the third node, we are forming the second element. Clear? Done. So initial node is 2 and final node is 3. Initial node is 2, final node is 3. Clear here? After that, I told you length of the element we need to find out, as well as we need to find out the value of L and M we need to find out. How to find? Because we have the formula. For the element number 1, L is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So here, come to the first element number 1. Here, x2. Here, x2 minus x1, 750 minus 0, 750 minus 0 whole square plus 500 minus 0, y2 minus y1. y2 is how much is there here? 500. y1 is how much is there? 0. 500 minus 0 whole square. After that, if you're 750 whole square plus 500 whole square, if you're squaring both the terms, then you will get the value is 812.5 into number of 3. If you are taking the root, then you will get the answer is 901.39 mm. Clear? The length of the element, first one, how much we got here? 901.39. we need to substitute in the element connective table. We need to substitute in the element connective table. Clear? After that, we need to find out the value of L as well as we need to find out the value of M. The same concept we need to follow for the entire unit. Is it right? Let us see. L is equal to x final load minus x initial load by LE. Here, x final load, nothing but x2 minus x1. Clear? So, x2 value is how much is that here? 750 minus 0 by LE value is how much is there? 901.39. If you divide the value, then you will get the answer is L is equal to 0.832. Clear? After that, we need to find out the value of M. So M also called as sin theta. What we can say here? Sin theta. L also called as cos theta. Okay. M is equal to y final load minus y initial load by LE. So y final load nothing but y2 minus y1 by LE. So here y2 is how much is there? 500 minus 0 by LE value is how much we got here? 901.39 mm. If you divide the value, then you will get the answer is M is equal to 0.55. Clear? After getting the value of L and M, we need to substitute in this first element table. If you substitute here, L value is how much we got here? 0.8832 and M value is 0.555. Clear? After that, same concept we need to follow for the element number 2. The same formula we have to use. But if you want to joining the element 2, when we will get here? If you joining the second node to the third node, then only we will get the element number 2. For that reason, we have to use the formula x3 minus x2 whole square plus y3 minus y2 whole square equal to, here x3 value is how much is that here? We have the x3 value is 0. Clear? x3 value is here 0 and x2 value is 750. 0 minus 750 whole square plus y3 value is how much is that here? We have the y3 value is 500 minus y2 value is how much is there? Again we have the value of 500 whole square. After that, this should be cancelled. The remaining should be 750 whole square. So if you cancel the square and root, then you will get the answer of 750 mm. Clear? After getting the LE value, length of the element, we need to find out the value of L as well as we need to find out the value of M. We need to find out. For that reason, we have to use the formula is L is equal to x final load minus x initial load by LE. So here the x final load is how much is that here? You can take from the above value 0 minus 750 by LE value is how much we got? 750. If you divide this value 750 by 750, you will get minus 1. Clear? After that, we need to find out the value of M. M is equal to y final load minus y initial load by LE. So y final load nothing but what we can say here? I told you y3. Otherwise you can take from here also. y3 minus y2. y3 minus y2 by LE. So y3 values how much is that here? We have the value is how much? 500 minus y2 value is again 500. 500 minus 500 by length of element. How much we got it here? 750. So 0 by anything should be 0. Clear here? After getting the value of L and M, we need to substitute in the above elementary connective table in which we need to substitute this value. So L value is how much we got here? We got the answer is minus 1. Okay, how much? Minus 1. And M value is how much is that here? M value is 0. So please make the correction here. Instead of plus 1, make as the minus 1. Clear? After that, we need to go for elemental stiffness matrix. For elemental stiffness matrix, we know very well K is equal to AE. So area of cross sections of element of the first element or maybe second element, is it right? And E nothing but modulus of elasticity of the element by L E nothing but length of the element. L square nothing but we can say as cos square theta, m into L what we can say here cos theta into sin theta, minus L square nothing but minus cos square theta, minus ml nothing but minus cos theta into sin theta. Clear here? I hope so no one is having the confusion. Then we have to use this formula. After that, the same concept we need to follow for the element number 1, element number 2. Clear? Then for element number 1, k is equal to a1 e1, we have to use above formula. Okay dear? So for the first element already is given. How much is given here in the question? A1 is already given as 1200 mm. A2 is given as 1000 mm square. A1 is given as 1200 mm square, A2 is given as 1000 mm square. So we are using the first element, is it right now here? If you are using the first element, that's what we have to use. The area is 1200 into modulus of elasticity for the first element as well as for the second element is remaining same. How much is given here? 2 into 10 power 5. The length of the first element, how much we got here? We got the length of the first element is 901.13. How much we got here? The length of the first element we got as 901.39. So we have to take this value. L is equal to 0.832 and m is equal to 0.55. You need to substitute in this above matrix. Clear? So after that, L, how much we got here? 0.832. Clear? Here 0.832. We need to substitute here 0.832 whole square. Again 0.832 into 0.55. If you multiply, then you will get this matrix. Same concept we need to follow. Clear here? After that, first of all we need to divide this value. Divide this value. Clear here? So if you divide this value, then you will get the answer is 2.66 into 10 power 5. After that, what we have to do? So this 2.66 we need to multiply by 0.692. If you multiply by 0.692, it will become as 1.84. Again 2.66 if you multiply with 0.462, then you will get 1.22. Again the same concept we need to follow up to the last end. The 2.66 into minus 0.692, if you multiply, then you will get the answer is minus 1.84. Again we need to multiply 2.66 into 0.462, then you will get the answer is minus 1.22. The same concept we need to follow up to the last end. Just you need to multiply this 2.6 to the whole the matrix. Clear? After that, we need to represent first, second, third, fourth, because we have the 4 column. For that reasons we need to represent, this is first column, second column, third column, fourth column. But remember one thing, this first node to this first and second row, what we can say node 1, this first and second column, what we can say node 1, and third and fourth, this one, what the third and fourth column, what we can say node 2. First and second, what we can say node 1, third and fourth, what we can say node 2. Clear? So if you are joining the first node to the second node, then we are forming the first element. Clear? If you are joining the first node to the second node, we are forming which element here? First element. If you are joining this first node to the second node, we are forming which element here? We are forming the first element. After the same concept we need to follow here also. For K2 is equal to A2 E2 by L2, the same formula we have to use. The same matrix we have to use. L square ml minus L square minus ml, ml m square minus ml minus m square minus L square minus ml, L square ml minus ml minus m square ml and m square. Clear? After that, we have to use this formula. Area of the second element, how much we got here? We got as 1000. And modulus of elasticity of the material, how much is there? 2 into 10 power 5. The length of the element L2, how much we got here? We got as 750. If you divide If you put in this value, then you will get the answer is 2.67 into 10 power of 5. As well as if you substitute this L equal to minus 1, M equal to 0, then you will get this value. L equal to how much? Minus 1, M equal to 0. So minus 1 whole square should be how much? Plus 1, and this become how much? 0 into anything should be 0. Then you will get this matrix. After the getting this matrix, then again just you need to multiply 2.67 into 1, you will get 2.67. Again you need to multiply 2.67 into minus 1, minus 2.65. Again 2.67 into 0 should be 0. 2.67 into minus 1, it become as minus 2.67. If you multiply 2.67 into 1, it become as 2.67. Okay. After that 1, 2, 3, 4 is completed. Again we have to go for 3, 4, 5, 6. So this 3, 4, what we can say, I told you, this 3, 4 we can say as node number 2. And 5 and 6, what we can say here, 5 and 6 we can say as node number 3. If you are joining the node 2 to the node 3, then you are forming which element here? Element number 2. You are forming the element number 2. If you are joining second node to the third node, you are forming the element number 2. Clear? After that we need to add the all elemental stiffness matrix. So the step number 4, in the step number 4 we need to find out the global stiffness matrix. Global stiffness matrix should be, it is the equal, the global stiffness matrix, it is the product of elemental stiffness matrix. Clear? But here how many elemental stiffness matrix we have? We have only 2 elemental stiffness matrix. So which one is there? K1, the first elemental stiffness matrix, and plus K2 nothing but second elemental stiffness matrix. K is equal, K nothing but global stiffness matrix should be equal to first elemental stiffness matrix plus second elemental stiffness matrix. Okay, so how many node we got it here? Point here, let us see, 1, 2, 3, 4, again 5 and 6. So again you have to repeat 1, 2, 3, 4, 5, 6 in the row as well as in the vertical. 1, 2, 3, 4, 5, 6. Clear? And how to multiply, that is the most important here. Let us see. First you need to multiply this first node to the first node. How much you will get here? 1.84. Clear? Here 1.84. Again first node to the second node, how much you will get in here? 1.22. 1.22. Again first node to the third node is how much you get in here? Minus 1.84. Minus 1.84. Here first node to the fourth node, how much you get in here? Minus 1.22. Minus 1.22. Again first node to fifth node is available here? Not available. Come to the second here, first node to the fifth node is available? Not available. If it is not available, then you need to consider this value as 0. First to fifth, 0. We don't have any matrix. First to 6, we don't have any matrix. For that reason we are representing as 0. Clear? After that, come to the point here, second node to the first node is how much is there? 1.22. Second node to the first node is 1.22. Again come to the here above matrix, second node to the second node is how much we got it here? 0.816. 0.816. Again here second node to the third node is minus 1.22. Second node, how much we got here? Minus 1.22. Again check in above matrix, second node to the fourth node, how much we got here? Minus 0.816. Minus 0.816. Again second node to the fifth node is available here? Not available. Come to this second elemental stiffness matrix, second to the fifth one is available here? Second to fifth is not available here. For that reason we are considering as here 0. 2 to 5 also 0. 2 to 6 also 0, because it is not available in above elemental stiffness matrix. If it is not available, then you need to consider the value as 0. Clear? Then again third one, let us see. Third node to the first node, how much you got in here? Minus 1.84. Minus 1.84. Again, third node to the second node is minus 1.22. Minus 1.22. Okay, dear. Again, you have to check it here. Third node to the third node. How much you get in here? 1.84. Again, you have to check here. Third node to the third node. How much you getting? 2.67. 1.84 plus this 2.67. Clear? Again, you have to check it here. Third node to the fourth node. Third node to the fourth node. How much you get in here? 1.22. 1.22. Again, third node to the fifth node is available. It is available. How much you get in the value? Minus 2.67. Minus 2.67. Clear? So third node to the sixth node, how much you get in the value? 0. The same concept we need to follow up to the 6. Clear, dear? I hope so. No one is having the confusion up to here. After getting the value of global stiffness matrix, we need to find out the equilibrium equation for the given continuum. If you are finding the equilibrium equation for the given continuum, we have the formula is global stiffness matrix into nodal displacement equal to nodal force. What is the formula is that here? Global stiffness matrix into nodal displacement equal to the nodal force. So K value how much is there here? This whole matrix we have to represent here. 1.84, 1.22 minus 1.84 minus 1.22, 0, 0. The whole matrix we have to represent wherever K will be there. And Q nothing but the nodal displacement. Q1, Q2, Q3, because how many nodes we have? 6 nodes. For that reason we have to present here Q1, Q2, Q3, Q4, Q5 and Q6 equal to F is indicate that nodal force. How many force we have? Total 6 nodal force we have. F1 equal to 0, F1, F2, F3, F4, F5 and F6. Let us see over here. Here the node 1 and node 3 is fixed. If node 1 and node 3 is fixed, then this value become as 0. Clear? Done. So for that reason, this Q1 value is 0 as well as Q2 value also 0, because at the node 1 Q1 and Q2 is acting. At node 1 Q1 and Q2 is acting. For that reason, Q1 also 0 and Q2 also 0. At node 3, where is the fix? At node 3, this is also fixed. At that time, this Q5 and this Q6 also 0. At node 1 Q1, Q2 is 0. At node 3 Q5 and Q6 also 0. That's what we have to represent here. That's what clear. Q1 equal to 0, Q2 equal to 0 and Q5 equal to 0 and Q6 equal to 0, because of it is a hinge support or fixed support is acting at a node of 1 as well as at the node of 3. If it is fixed, the Q1 we need to eliminate this first row and this first column, and Q2 also 0. We need to eliminate the second row, second column. Clear? And Q5, this Q5 nothing but this Q5 we need to eliminate fifth row and this fifth column, and Q6 also 0. 6th row and this 6th column will cancel. Clear here? Then let us see the force F3. Force F3 is how much is there? It should be 0. And force F4, which force is acting here? Compressive force is acting. So that's what we need to consider as minus 50. Let us see again. I will show you the figure, then you can easily understand here. Let us see this Q3 value is how much is that here? It is become as 0. This Q4, I will enlarge this value. So which type of the force is acting at a point of 2 here? So compressive force is acting. If the compressive force is acting, then we need to consider as minus which value here? The nodal force how much is there? This nodal force F4 is acting in a downward direction. If it is acting in a downward direction, we need to consider as the minus. or this symbol is indicate that the compressive force is acting at a point of 2. So minus 50 into 10 power of 3 we need to represent. Clear? Okay, minus 50 into 10 power of 3. After that, which part is not eliminated? Only this part is not eliminated. This third and fourth is remaining. So just we need to add this value. Clear? So here remaining is, if you add 1.84 plus 2.67, then you will get the value is 4.51. Again is 1.22. Again is here 1.22, here 0.816. We can represent here Q3 and Q4 equal to F3 value is 0 and F4 value is minus 50 into 10 power of 3. We can represent. After that, remember, first of all, how to multiply, that is the most important. This row, okay, this row into this column, this first row into this first column, second row into the second column. First, what I am doing here, first we are multiplying this first row into this first column. 4.51 into Q3 plus 1.22 into Q4 equal to, the first row value is how much is there? 0. If you divide 10 power of 5 by 0, should be become as 0. Remaining should be 4.51 Q3 plus 1.22 Q4. After that, 10 power of 5 as it is. This second row into this column. 1.22 into Q3 plus 0.816 into Q4 equal to minus 50 into 10 power of 3. Clear here? This 10 power of 5 we need to divide here. Clear? Then you will get the value is 1.22 Q3 plus 0.816 Q4 equal to minus 50 into number of 3 divided by 10 power of 5. After that, we need to write in the above matrix. This is the first matrix, or we can consider as the first equation, or it is considered as second equation. Clear? First equation, we are adding in the systematic form 4.51 Q3 plus 1.22 Q4 equal to 0. We are arranging this form. Okay dear? And 1.22 Q3 plus 0.816 Q4 equal to minus 50 into the above 3 by 10 power of 5. Then how to multiply this value? Always remember, please always remember, this first point just you need to multiply here. 1.22, okay, and this above value you need to multiply in the bottom. Then you will get some value, exact value you will get. So after that, if you multiply 1.22 into 4.51, it becomes as 5.50 Q3 plus 1.22 into 1.22, it becomes as 1.49 Q4 equal to 0. If you multiply 0 into anything, should be become as 0 only. Clear? Then again 4.51, only 4.51, is it right? You have to multiply 4.51 into 1.22, it becomes as 5.50 Q3 plus 4.51 into 0.816, it becomes as 3.68 Q4 equal to, if you divide this value 50 into the power of 3 by 10 power of 5 into 4.5, then you will get the answer is minus 225 to 25.5 into the power of 3. So after that, our intention is we want to cancel the terms. For that reason, instead of positive sign we are using the negative sign, instead of positive sign we are using the negative sign. Here instead of negative sign we are using the positive sign. So here above is positive, below is negative, that these terms will be cancelled. The remaining should be 1.49 minus 3.68. If you subtract this value, then you will get the answer is minus 2.19 Q4 equal to this. How much is that? Minus 225.5 by 10 power of 5. Keep as it is only. Clear dear? Then after that, if you divide this value, then you will get the answer is Q4 equal to minus 1.03 mm. Clear? So we got the value of Q4. The Q1 is 0 and Q2 also 0. Q5 also 0, Q6 also 0. We got the value of Q4 is how much, dear? Minus 1.03. Again, what we need to find out? We need to find out the value of Q3. Then so we need to substitute this Q4 value in above equation. Any one equation you can use. So I am using this first equation. Okay, substitute Q4 value in above first equation. So 4.51 Q3 plus 1.22 Q4 equal to 0. So this is Q3 as it is. This plus, if it is moved toward this side, means it become as minus 1.22. Q4 value is how much is there? Minus 0.103 by divided by 4.51. If you divide the value, then it will become as 0.279 mm. So we got the value of Q3 is 0.279 mm and Q4 value is minus 1.03 mm. So we got the answer of Q1. The nodal displacement Q1 is 0, Q2 also 0, and Q3 value we got as 0.279 and Q4 value is minus minus 1.03, and Q4 value Q5 value is 0 and Q6 value also 0. Clear? Because why it's 0? Q1 Q2 is fixed at a point of 1. For that reason Q1 Q2 is 0, and the node 3 is fixed. For that reason Q5 Q6 also 0. Clear? Again, what we need to find out? We need to find out the value of Q3 and Q4. We got it. After getting the value of Q3 and Q4, we need to find out the stresses in each element. The same concept we need to follow for the first element as well as for the second element. How many elements we have in this figure? We have only 2 elements. Element number 1, element number 2. That's it. Clear? First of all, we need to find out stress in each element. For the element number 1, we need to find out. So instead of sigma, we have to represent here sigma 1 stress of the first element equal to modulus of elasticity of a material, length of the element minus L nothing but minus cos theta, minus M nothing but what we can say here, minus sin theta, cos theta as well as sin theta. Here if you want to join first node to the second node, we are forming which element here? First element. For that reason we are presenting here Q1 Q2 Q3 and Q4 Q1 Q2 Q3 and Q4. So the modulus of elasticity or Young's modulus values, how much is that? 2 into 10 power of 5. The length of the element, how much we got here? 901.39. L value is how much is there? Minus 0.832. M value is minus 0.555 and L value is 0.832. M value is 0.55. Q1 is fixed and Q2 also fixed and 0 0. Q3 is 0.279 and Q4 is nothing but minus 1.03. After that, if you divide this whole the value, then you will get the answer of 221.88. First of all, we need to multiply this first row into this column. Minus 0.832 into 0, it become as 0. Minus 0.55 into 0, it become as 0. 0.83 into 0.27, it will become as 0.279. Okay. After that, 0.55 into minus 1.03, it become as minus 0.572. If you subtract this value, then you will get the minus 0.293. If you multiply this value, then you will get the answer is minus 65.10 Newton per mm square. So which type of the force is acting at the element number 1? The compressive force is acting. Why it is a compressive force? Because of we are getting the value is in negative. For that reason, if you are getting the values in negative, for that reason we need to consider as compressive force is acting for the first element. For the element number 2, sigma 2 is equal to E by L2 minus L minus M L M. Again, for the element number 2, if you want to find out the element number 2, then you need to join the second node to this third node, then you will get the element number 2. So Q2, Q3, Q4 and Q5. Q2 value, how much is there here? We got the answer is 0. Q3 already we find how much? 0.279. Q4 how much we got here? Minus 1.03. Q5 value is also 0. The same concept we need to follow here. 2 into number 5 by 750. If you divide, then you will get the answer is 266.67. Clear? Again this row into this column. 1 into 0 it become as 0. 0 into 0.279 it become as 0. Minus 1 into minus 1.03. Minus into minus it become as plus. 1 into 1.03 it become as 1.03 plus 0 into anything should be become as 0. After that you need to multiply this value to 66.67 into 1.03, then you will get the value of sigma 2 value is 274 0.67 Newton per mm square. So we are getting the values in positive. If the positive will be there, so we can understood that the tensile force is acting at the second element. Which force is acting? Tensile force. At the element number 1, which force is acting here? Compressive force is acting. At the element 2, which force is acting here? Tensile force is acting on the second element. After that, the most important thing is we need to find out the reaction forces. So we know very well this first node, second node and this third node. This first node is how is it? It is a hinge support. If it is a hinge support will be there, the normal reaction two sides is acting. One is the horizontal direction, another one is the vertical direction they acting. R1 they acting in the horizontal direction, R2 is they acting in a vertical direction. Clear? Again, here the normal reaction is R3. There is no forces acting at this point. For that reason it become as 0 value. Here at the pinpoint, at the node 2, which type of the force is acting here? Compressive force. How much? 50 into 10 power of 3. So opposite, the which force will be acting here? The normal reaction R4 is acting at the pinpoint. Clear? Then because it is also fixed, if it is fixed will be there, the two force will be acting. If it is hinge support will be there, then two normal reaction is acting. One is the horizontal, another one is vertical normal reaction is acting at this point. So at the node 3, the normal reaction R5 and R6 is acting at a node of 3. Clear? After this, we need to find out the normal reaction. We need to find out. So how many reaction we got here? Total 6. First of all, you have to write down R1, R2, R3, R4, R5, R6 equal to K nothing but global stiffness matrix, Q nothing but the nodal displacement, minus F is indicate that the nodal force. So K, the same value we need to keep here, above value, and Q nothing but the same, Q1, Q2, Q3, Q4, Q5, Q6 value we need to substitute here. Q1 value is 0, Q2 also 0, Q3 already we have solved the problem, already we have solved. How much we got in here? 0.279, and Q4 value is how much we got here? Minus 1.03, and Q5 value is 0 because of it is a fixed end, and Q6 also fixed end, minus. So at the node 1 there is no forces acting. For that reason we have to consider as 0. At the point 2 there is no forces acting. For that reason it is considered as 0. At the point 3 there is no forces acting. For that reason it will be considered as 0. But at the node 4, or we can say as the normal reaction is acting where, let us see over here, this is first, second, third is 0, fourth, which force is acting? 50. Which force is that? Compressive force. Which force? Compressive force. Minus 50 into number plus 3. Again here at point 5 and 6 there is no force is acting. For that reason it will be considered as 0 and 0. Again, you know very well how to multiply this one. First of all, I told you this first column into this column into this column you have to multiply, or another process also there. 1.84 this row into this first column, you can do it. It is your wish. Okay, Nadia? Then let us see. 1.84 into 0, it become as 0. 1.22 into 0, it become as 0. Minus 1.84 into 0, it become as 0. Minus 1.22 into 0, it become as 0. Minus 1.22 into 0, it become as 0. 0 into anything should be 0. 0 into anything should be 0. This overall the first column becomes 0. Again this second also be 0 because the whole column we are multiplying with 0. For that reason this value also be 0, and this 5 also becomes 0, and this 6 also becomes 0. Just you need to multiply this value only. Okay, this third column into this third row. Clear? Minus 1.84 into 0.279, it become as which one? Minus 0.513. Minus 1.22 into 0.279, it become as minus 0.34. So if you add this value 1.84 plus 2.67, after that you need to multiply with 0.279, become as 1.26. Again 1.22 into 0.279, it become as 0.34. Minus 2.66 into 0.279, it become as minus 0.74. 0 into 0.279, it become as 0. Again this fourth one, minus 1.22 into minus 1.03. Minus into minus, it become as plus. 1.22 into 1.03, it become as 1.26. If you multiply minus into minus, it become as plus. 0.816 into 1.03, it become as 0.84. And 1.22 into minus 1.03, if you multiply, it become as minus 1.26. The same concept we need to follow up to the bottom here. 0.816 into minus 1.03, it become as 0, and 0 into anything should be become as 0 only. After that, remember, that is the most important, you need to add this overall row. If you add this first row, it become as 0.747. If you add minus 0.34 plus 0.84, you will get 0.5. If you add 1.26 minus 1.26, you will be get 0. 0.34 minus 0.84, it become as minus 0.5. If you add minus 0.74, because here no in positive above the 1 value, is it right? So for that reason we can consider as minus 0.74. we can add, as well as here also overall 0 only. Clear? After that, the same matrix we have to represent here also. Just we need to subtract this value. Okay, 0.747 into 10 power of 5. 0.747 into 10 power of 5 minus 0. First row. Again 0.5 into 10 power of 5 minus second row. Again 10 power of 5 into 0 minus 0. 10 power of 5 into minus 0.5 minus into minus plus 50 into 10 power of 3. Again 10 power of 5 into 0.74 minus 0. 10 power of 5 into 0 minus of 0, it becomes as overall 0. Then if you add this whole the value, then you will get the value is 74700. If you add this value, then it become as 50,000. It becomes as 0. If you add this value, it become also 0. Again if you multiply here, you will get 74,000 minus 74,000. Again this value should be become as 0. So we got it as R1 value is 74700, R2 value is 50,000, R3 value is 0, R4 value is 0, R5 value is minus 74,000, R6 value also 0. For we understood that after that we need to draw the result. The result is most important in carrying the minimum 3 to 4 marks. If you represent the result, then you will get the 100% marks here. Then first of all, what we have to represent in the result? First of all, we have to write down the nodal displacement, because already we find q1 value is 0, q2 also 0 because of it is a fixed end, and q3 already we find, q4 also we find, q5 and q6 it is a fixed end. For that reason q5 and q6 value is become as 0. And after that, second one we have to represent here the reaction force or support reaction. We can say that R1 value already we find, R2, R3, R4, R5, R6 we have to represent. After that, elemental stiffness matrix we got sigma 1 is equal to minus 65.01 Newton per mm square, and sigma 2 is 274.67 Newton per mm square. We got the stress. Okay dear, I hope so no one is having the doubt regarding this problem. If you have the doubt regarding this problem, please write down in the comment box, and here please like, share and subscribe my channel here. Thank you.